Hello everyone, what's up? Welcome to CP Addict. In this video, we are going to look at the third problem from today's LeetCode Weekly Contest 205. It is called Minimum Deletion Cost to Avoid Repeating Letters. So in this problem, we have been given a string s of some length and we are allowed to delete any number of characters, and after deletion, our string must not contain any adjacent characters which are similar. So all the adjacent characters should be distinct, and we have been given a cost array which basically tells us how much will it cost to delete the ith character from our string. So as you can see in example 3, if we delete the first and last character, our final string will become ABA, and the cost it will take would be 1 plus 1, which is 2. So we need to delete the characters in such a way so that our used cost is minimized. That is, we are spending as less as we can. Now, length of the string can be at most 10 to the power 5, and yet let's see what we can do. So, I'm assuming you know about dynamic programming and what are the basic concept behind dynamic programming and what are the states which we use whenever we are building a recursive dynamic programming solution. So whenever we are going ahead in our string, that is in this problem, we only need to let us only care about the previous character from the current one. Suppose we are at some current character and it is x. Let us only care about the previous character which was there when we are forming our string and when we were at the previous character. Let's say it is y. Okay. So if the current character is similar to y, that is they both are same, we cannot have x at this place. And yes, if we have moved to the current location, we are assuming that we have already built the string. We have already processed our string till this part, that is till current index. Then we are not allowed to change the string which is behind the current index. So previous cannot be changed. We can only change the current one. So if pre is equal to current, then we need to delete current. There is no other way around, because we cannot have similar adjacent elements. So in this case, what we would be doing, we will have the previous as same. We will delete this current and move ahead with our recursive call. This is for one case. In the second case, when previous is not equal to current, that is the previous character of our string is not equal to current, then we have two choices. Either we can delete the current character, or we can use it and we can concatenate it on our your currently built string, which is the running string which we are using. Okay, so in this case, when we are deleting the current character, suppose this is previous, this is the current, and this is next. So we will delete this and we will move ahead with the recursive call. In this, we are not deleting the current, we are concatenating current to the previous and then moving ahead with the recursive call. So for next, previous will be equal to current, and in this case, for next, previous is equal to previous, that is, it did not change. Now you might be thinking, in this case, when previous is not equal to current, why we are deleting the current character, as it is not causing any problems at this moment. Well, there might be a case. Let's take an example. Suppose we have a string A, B, B. Okay, and the cost to delete this character is 10, but the cost to delete this character is 100. And suppose we are at this point. Now see, at this point we see that A is not equal to B. So if we do not delete this one, that is this character, then our string will become AB, and when we go ahead we'll see the third B, which is this one. Now we cannot have this B, so in that case we will need to delete this B, which will cost us 100. But in the other way around, the other case, when we are deleting B, so at this point when we see this B, it is not equal to A, but still we deleted it, so it did cost us 10. But when we moved ahead with the recursive calls, we saw the third B. We see that it is not similar to A, which is the current previous. So we do not delete this one. So our string becomes AB. Even in that case, our string was AB, but here we only spent 10 units of money, you can say, or any other quantity. But here we used 100 units, and we need to minimize the cost. Okay, so this is why we were considering both the cases. Let's see the code now. It would be more clear now. So I have initialized my DP array. This is the length of my string, and this is for previous. From A to Z, I'm considering all the characters. That is, 0 represents A and 25 represents Z. I have initialized my DP array to -1, then called my solve function, which is this is the current index IDX. This is the previous, which basically tells me what is the previous character of my string, which I'm currently building. And this is the string and cost. I see if I've moved to the end of my string, I'm simply returning 0, as there are no more characters to delete. If I see that the value of that DP array is not -1, I'm returning, because it means I've already solved this sub problem. I do not need to solve it again. Now I'm finding out the solution for this current problem. I'm initializing it to the maximum value I can have in an integer. Then I'm seeing if the previous is similar to the current one. Like this is the current character, and this is the previous. If they are same, we have no other choice but to delete the current one. So for deletion, we need this much cost, and then we are moving ahead with the recursive call. Now, as we have deleted the current one, previous remains to be the same. So we have passed previous in previous argument. Else here, if we have moved to else, it means the previous is not equal to current. Now we have two choices. Either we can move ahead with a recursive call and add the current character, so our previous becomes current, as you can see here. And in second case, we are deleting the current. In the second case, we are deleting the current character. So it cost us cost of IDX, and now previous remains to be same. Okay, it does not change. And at the end, we are taking the minimum out of it, because we had two choices and we need to minimize the cost. We're returning the answer. So I hope you like the video. In the next few videos, I would be coming up with the solution of other two problems. If you have any doubt, let us know in the comment box, and any suggestions as well, please let us know in the comment box. Okay, take care. Do subscribe to our channel if you like our videos. Take care. Sayonara.